Kia ora Year 12. This video is going to do questions 1 and 2 from paper 71 of the May-June 2018 A-level stats paper. I'm going to try and split the whole paper up into about 5 videos to keep them pretty short. So this one has got two really straightforward little questions. The first one is quite predictable and comes up all the time, and that is to find unbiased estimates for the population mean and the variance of x. So an estimate for mu is going to be equal to this, sum of the x's of all the values divided by n. So that gives me 153.2 over 75, which is 2.04, right? Remember from last week, we are always rounding to 3 significant figures. Okay, next up, the estimate for the population variance. Now with this one, we've got to be a little bit more careful. The formula that I like to use is this one. Whoops, there's that divided by n. So if we substitute in from above, we're going to use all 3 of these. This is what we get. So we get 1 over 74 times this. So just be careful with all the little things in here, like your brackets on your calculator. And that should give you 0.369. The reason I like doing it this way is that we're not using a rounded value for the mean. If you do use the alternative formula, make sure that instead of using 2.04, that you carry through the full value from up here and use that, so we don't want any premature rounding. Okay, so that's the first question, very boring 3 marker. On to something a bit more interesting, slightly more interesting, not much more interesting. The 6-sided die that you've got is suspected of bias. The die is thrown 100 times and 2 comes up 20 times out of 100. And we're going to call the probability of getting a 2 on any throw P. So we have to build a confidence interval for that population proportion. Okay, so the 94% confidence interval will go like this. It'll be p hat, my sample proportion, plus or minus my margin of error. And the margin of error has got the following bits. It's got something out of the normal distribution. Right, and this is my standard deviation for a sample proportion. So working through the question, we've got p hat is 20 out of 100, which is 0.2. And we want to have a value of z that chops off 3% in each tail. Okay, so that for the 94% z value, we're going to have 3% up here and 3% down here. So in your tables, if you use your tables, you'll find 1.881. It's really important that you can find that value. So go and check that you can do that now. Okay, and now we're ready to build the confidence interval. So we start with the 0.2, the p hat goes in the middle, plus or minus 1.881 times 0.2 times 0.8 over 100. So when we work that through, we get a 94% confidence interval for P, the population proportion, goes from 0.125 up to 0.275. And I'm going to turn that into percentages now. So 94% CI for P is from 12.5% to 27.5%. Now, before you even read the next question, you can probably guess what it's going to be. Have we got evidence or not that the die is biased? And that is what the question says. So here we are. Use your answer to part 1 to comment on whether the die may be biased. And it's only worth 1 mark. What we're looking for is whether what we would expect from an unbiased die is in that confidence interval. Okay, so all we've got to write is something like this. Since 1/6 is roughly 16.7%, is within the confidence interval, we have no evidence of bias. Okay, so just because we saw 20% was my p-hat, that's not enough evidence to conclude that the dye is biased, because we know that every time we take a sample, we'll get different results. And you'll hear that phrase a lot when you do level 3 stats next year. So the big idea here is sampling variability, and the margin of error measures that, right? So it goes from 12.5% up to 27.5%. And because what we would see if it's unbiased is 16.7%, that's within my range of values given the dye that I've got. Okay, so hopefully that makes sense. I will come back later on, probably tomorrow, and do questions 3 and 4. Thanks for watching.